Okay, so let's look at another example, a second example of balancing redox reactions in acidic conditions. So here is my problem. So I'm going to say I have the dichromate ion plus zinc solid produces zinc 2 plus ions plus chromium 3 ions. Okay, so again, I'm going to write the instructions down the side and as we're doing them. So first, I'm going to write out half the reactions. Well, first, I'm going to assign the oxidation numbers. Okay, so I'm going to start with the easy one, which is zinc. So zinc solid has an oxidation number of 0, and because it's a monatomic ion, zinc 2 plus has an oxidation number of positive 2. So that's easy. The oxidation number is increasing. This is the oxidation half reaction. So now the reduction half reaction, what's reducing is chromium. Oxygen can't be oxidized or reduced. So I know that chromium is reducing because I already have the oxidation half reaction, so the one that's left is the reduction half reaction, but we still need to assign the oxidation numbers. So the oxidation number for chromium here for plus 3 is positive 3. So now we need to figure out what is the oxidation number of the chromium in this dichromate ion. So again, I'm just going to write this over here, Cr2O7, which has an overall charge of 2 minus. It means oxygen we know has a charge of -2. So chromium is what we don't know. So something, 2 times something, whatever chromium is, plus oxygen is -2, 7 times -2 equals -2. So 7 times -2 is 14, so -14. 2 times something plus -14 equals -2. So that means this term here must be positive 12, which means this must be positive 6. That means chromium must have an oxidation number of positive 6. So yes, it is reducing from positive 6 to positive 3. So we've assigned oxidation numbers. Now let's balance the half reactions. So let's do the oxidation one first, because the oxidation one is easy. So I have zinc solid to zinc 2 plus. So the only thing I can do to balance an equation with electrons is add electrons to the more positive side of the equation. I'm balancing the charge. So this side has a charge of 0. So now this side has a charge of 0. So now this is balanced. So now let's move on to the reduction half reaction. So the reduction half reaction, first I'm going to balance. So the oxidation half reaction is balanced. For the reduction half reaction, first I need to balance the element being reduced. So the element being reduced is chromium. So now I'm going to write this out. So the element is not balanced because on this side I have 2 and on this side I just have 1. So that means I need to multiply this whole side by 2. So balanced element being reduced. So I did that. I'm going to write it down here. Here's the dichromate ion. So now I have 2 chromium 3 plus. These are both aqueous. So that's the first thing to do. The next thing to do is to balance the oxygens by adding water. balance oxygens by adding liquid water. I'll write that over here too. Okay. So this side has 7 oxygens, which means I must need to add 7 waters to this side. Plus 7 water. Okay, now the oxygens are balanced. Now the next thing I'm going to do is I'm going to balance hydrogen by adding hydrogen ions, aqueous. So this side has 14 hydrogen ions, which means I need to add 14 hydrogen ions to my reactant side. Okay, so we've balanced the element, we've balanced the oxygens, we've balanced the hydrogens. Now the last thing to do is to balance the charge by adding electrons. Okay, so remember we can only balance with electrons by adding electrons to the more positive side. So this side of the equation has a charge of positive 6 because I have 2 times positive 3. This side has 14 minus 2, it has 12. So if this has 6 and this has 12, that means this side needs 6 electrons, so that I have a charge of positive 6 on both sides. Okay, so now the reduction half reaction is balanced. Now I need to combine the half reactions so that the electrons cancel. Okay, so let's go way back to up here. Up here, my oxidation reaction had 2 electrons on the product side. Down here, my reduction half reaction has 6 electrons on the reactant side, which means I need to multiply this whole thing by 3 so that I have 6 electrons on both sides. So I'm going to say zinc 3 zinc solid gives me 3 zinc ions, zinc 2 plus ions, plus 6 electrons. Now my electrons can cancel. I am going to, this is my balanced oxidation half reaction, ready to add to my balanced reduction half reaction. Now I'm going to add them together. I'm going to rewrite them both just so you can see what I'm doing. So I'm going to say 3 zinc solid, 3 zinc 2 plus 6 electrons. Electrons are aqueous. Okay, so now 6 electrons plus 14 hydrogen plus the dichromate ion produces 2 chromium 3 ions plus 7 water. Okay, so I'm going to add these two together. The number of electrons will cancel. So I'm going to say 14 hydrogen ions plus the dichromate ion plus 3 zinc produces 2 chromium 3 plus 7 water plus 3 zinc 2 plus ions. So that is the balanced redox reaction in acidic conditions. So these can be kind of tedious. Just remember what you're doing. You want to balance the oxidation reaction, balance the redox, the two half reactions, and add them together. The oxidation reaction, you just need to balance the charge with electrons. The reduction half reaction, you have to balance the oxygens by adding water, then the hydrogens by adding hydrogen ion, and then the charge by adding electrons. Then make sure you have equal number of electrons on opposite sides to add everything together.